Hey there, YouTubers. This is a pretty unplanned talk. I'm going to talk about operators in the sense of in mathematics we have operators. I just tonight wrote this, I'm going to say a little bit weird essay because, or story as we call it in Medium. I'm blending some kind of dry mathematical thoughts about what operators we are used to, obviously plus, minus, divide, multiply. So I could talk about each of these operators, right, at length. But in general, to add something is to subtract 3. 2 minus 3 is the same as adding the additive inverse of 3. So if you know what additive inverse means, we just put a minus in front. And the same with division. When we say 8 divided by 9, we're really saying multiply 8 times the inverse of 9. And that's how we can do the inverse like that, right? So we learn about those 4 operations. And then the question is, do we ever learn about the modulo operator? Div mod is another one. And in Python, it's like if I have 9, how many times does 2 go into that, and what's the remainder? And we know the remainder would be 1. If I have 100, how many times does 99 go into that? Well, obviously once, and the remainder is 1. The div mod, we can get some help on that. It gives you back, this is interesting now, it gives you back the x double slash y. So let's do 109. X double slash y is it goes in exactly 11 times and no more, and then the remainder, right? Double slash in Python means the integer division, like 9 goes into 8 0 times. That used to be the intrinsic division. If you just said 1 slash 2, you would get back 0 in Python 2. But Python 3, that got fixed as Guido sees it, and I think we agree. So what about weird essay again? Well, I'm saying, one more thing I'm going to get to before the video's over is how to look up stuff in the Synergetics dictionary. Thanks to Bob Gray, Dr. Bob Gray. So this weird essay story is talking about how math is politicized, just like history is. Now, what I'm suggesting, here's my big conclusion, is that the dot operator, that's in Python, right? That's part of Python, is the next big operator to finally get the recognition it deserves as being part of math. Like if you have a class dog in Python that has no content at all, I still have enough information there to create a dog object like Fido. Fido's a new dog. Dog was just born there. And now if I want to give Fido a color, say brown, that's like an adjective or an attribute, easy to do. And now I can come back and ask, hey, what's Fido's color, right? And when I create Fido, maybe I want to give some behavior. So let's start over with my dog. And we'll have a method that all dogs have called bark. And it's going to be the self that barks. Every dog has a self. It's very metaphysical. And we're going to return, if you think of the word metaphysical the way I do, maybe not. But anyway, return the word bark, exclamation point, n times. So there's a dog with a behavior this time. So now if I create Fido anew with this new guy, now notice where the bark, where the dot comes in. Fido dot. So I'm reaching into. And what I'm claiming is with polyhedrons, geometric polyhedrons, we are going to have this concept of a container, front and center. We already have that. Polyhedrons are nothing new. But to be able to reach into it, and it's very important, say in Synergetics, that we think of a system as just a connecting around planet, having an inside, having an outside. Like the first thing you notice when you have a system is that you can talk about what's inside and what's outside the system. You can talk about its concave aspect and its convex aspect. You can start to spin it, because we're thinking of a physical or a metaphysical polyhedron when we talk like this, a thing, an object. The paradigm object might as well be a polyhedron. I mean, a dog has more detail. There's a lot more going on with a dog. But if you're just going to think of a generic object, how do we represent that? Well, you can make a circle. You can think of all these flat things. But why don't we just make it a polyhedron? And then it becomes, well, the math of polyhedrons is going to be the math that uses dot notation, because we're going to want to set the scale, rotate, translate. So that's what my essay is about, this kind of weird one. And I talk about the politicization of math because I want to say that the dot is caught up in politics too right now, as are polyhedrons. It's nothing new that math would be kind of a battlefield. And I think they don't teach that. They don't like you to know that, like, Kronecker thought Cantor was a nutcase and that Cantor actually did have to take refuge in an asylum occasionally, sanatorium, whatever. These mathematicians fight bitterly. They don't always have high opinions of each other. And that's been going on a long time. Newton, Leibniz, whatever. So teach that it is a big kind of fight, and yes, it makes sense that when everyone was being anti-German in the United States around the time of Prohibition, and President Wilson and all this, women getting the vote, etc., Germans became demonized a lot. And it was part of the World War I, the whole spirit of World War I. You may have trouble imagining a time when to be German American was to be suspect. You might be a traitor. We might haul you out of your house in the middle of the night and make you kiss the Constitution because you're German, even though you're an American citizen. This whole hysteria about Germany, that is a kind of forgotten chapter. If you don't study history, you just forget all this stuff. And how would that change what was in the schools, in math in particular? Well, according to one professor at University of California somewhere, actually there was a concerted effort to purge a lot of number theory kind of stuff from K through 12. And let's put in a lot more Euclidean geometry. Now, there's nothing wrong with Euclidean geometry, but there was a conscious decision that we don't want Gauss, for example, to be one of our heroes. He's German, and we are proud Americans, and we're not going to say sauerkraut anymore, and we're not going to study anybody named Gauss, okay? So there's that kind of, like, a wall goes up. And I'm not saying that the dot operator is caught in the same kind of politics. It's a whole different ball game, but there is politics. I'm just saying there is politics. So Fido dots bark 10 times, and there he does. Barks 10 times. I think that's a good place to end this. Thanks for listening. Oh, if you want to check the Medium article, it's linked in the notes. And I forgot, I was going to show you this cool Synergetics dictionary. I was showing you, like, I'm proud owner of, did I take it away already? I have the 4 volumes. Applewhite actually gave it to me as a gift, as physical dictionary, but the Synergetics dictionary is online. And if you want to look up the word precession, if I'm lucky, I can get right to the quote that I used in my last video. I'm just jumping ahead in sets of 50 cards. I started at the P's. I'm accelerating. Let's go 500 cards. Still got a precession's pretty far in the okay, dictionary, prime, otherness. I should slow down. Actually, I've gone too far, haven't I? E, F, G, H, I. So let's go back 50 cards. We're trying to get to precession here. 50 cards. I'd probably jump. Ooh, we're getting close now. Let's go back 20 cards. Precession. So remember how important that is in fuller thinking, that concept. And to just give you a sense of that, I'm just going back one card at a time to really give you a sense. C, social sciences. So analogy of precession and social behavior. I mentioned the cocktail party and stuff like that. So there's a lot going on in synergetics that you can't really, you need that kind of metaphoric mindset just to read this kind of stuff, don't you? It is definitely in the humanities, this kind of reading. Okay, so I'm not going to find the exact quote used in my, yes, there it is. Is that it? Gosh, this is close. The effects of all components of universe in motion upon any other component in motion is precession, and inasmuch as all the component patterns of universe seem to be motion patterns, in whatever degree they do affect one another, they are inter-affecting one another precessionally, and they are bringing about angular resultants other than the 180 degreeness. So it's a very wide net that he's casting here. Precession is basically how moving parts affect other moving parts. And in a way you could say it's kind of a cop-out, but I think of it more as the broadest brush. And then as a subcategory of precession, you have direct gravitational interattraction, which is more predictable. All right, so that's how to use the Synergetics dictionary. We'll talk to you soon.